The other law to help you solve for oblique triangles, triangles without a 90-degree angle, is the cosine law. So you're either using sine law or cosine law to solve for those triangles without a right angle. And now, today, I'm going to teach you about the cosine law. The law of sines work for the following. When you have an angle, another angle, and a side, or angle, side, angle. But what about for these following, when I have side, 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 and no angles? Or a triangle with SAS, side, angle, side. Sine doesn't work. This is where we need to use cosine. So if I have all three sides or a triangle with SAS. We need a different way to solve triangles that don't give us the connected pair, and this is the law of cosines. Now the formula is a bit more confusing, but I like it if you think of it like a bookshelf. And what we are solving for is at the ends of our bookshelf. So in the following example, either we know what A is, or we're trying to solve for it, or we're trying to solve for that last angle. And I am not one for wanting to memorize formulas. So let's look at an example. This one here has side, angle, side. So this is a triangle with SAS. I want you to ignore this for now. I am solving for a length. Length is your little, lowercase letter. This is going to start your formula. So that's our first bookshelf, our first end of the bookshelf. So we have x squared. And then I want you to leave a lot of space because at the very end, we have its partner, which is cos, and the angle is 32. So cos 32. In the middle, I call it the peanut butter and the jelly because we're making a peanut butter and jelly sandwich. The other two lengths are 12 and 15. It does not matter which order I put these in. So I'm going to have 12 squared plus 15 squared, subtract 2 times 12 times 15 times cos 32. So all of this, yes, we do have to remember that we are squaring both sides and then subtract 2 times those sides again. But it doesn't matter what order. It's my peanut butter, my jelly. And now I'm going to solve for x squared. And this is the best because it's already by itself. So this whole right side I could plug into a calculator. 12 squared plus 15 squared. Subtract 2 times 12 times 15 times cos 32. So let's go over to my scientific calculator. Clear it. Make sure it's in degrees. And I had 12. There's my squared. 12 squared plus 15 squared. Subtract 2 times 12 times 15 times by cos. And what was our angle there? Cos 32 equals 63.7. I'm going to write that down, and then there's one more step I have to do. Nope, 63.7. I need to remember to square root. X squared is equal to 63.7, but I have to square root to just get x. So the square root of 63.7. Square root my answer. 7.98. There's my length. All right, we need more examples. Next one. We're solving for an angle, and its partner is 8. So this is my bread of my sandwich. It's on the outside. So I'm going to start off with 8 squared equals, and then the other piece of bread that I'm ending with is cos of that angle. So we're going to call it cos P. The other two lengths are my peanut butter and jelly. So 9 squared plus 8 squared, subtract 2 times 9 times 8 times cos p. So what I'm solving for is either at the start or at the end. And because it's the angle, it's at the end. This one is not quite as easy to solve for as the last because I need to get p by itself, but I have all of this math involved. So let's work through it step by step. 8 squared is 64. 9 squared is 81. Plus 8 squared is 64. Oh, okay, sorry, I caught one of my mistakes. I, for some reason, was looking at 8, but I already used 8. I need 10 in there. So let's fix this. This should be 10 squared and 10 over here. There, messed up on my jelly. So 10 squared is 100, subtract 2 times 9, which is 18, times 10 is 180 cos p. All right, going to continue simplifying. I'm going to add 81 plus 100, which is 181, subtract 180 times cos p. Now, a lot of people want to do this, and it would be wrong. They always want to subtract 181 from 180. But 180 is multiplying cos p. They're stuck together. 181 is just being added on. I need to subtract it from both sides. So now I have 64, subtract 181. That's negative 117. Equals negative 180 times cos p. Okay, let's divide by negative 180 to get rid of that. I don't see my negative. Okay, all good. When I divide by 180, I just have to remember that a negative and a negative make a positive. So that should be positive 0.65. And it is that small decimal, and the reason why is because I have to do the inverse of cos, which is cos, negative 1. So there's my inverse of cos. So back to my calculator, have to do the inverse of cos of my answer, and I get 130.54. And that is my angle. Okay, we have that the posts of a hockey goal are 2 meters apart. Okay, so here's my quick picture. There's my net, which is 2 meters apart. A player attempts to score by shooting the puck along the ice from a point 6.5 meters from one post and 8 meters from the other. Within what angle must the shot be made? So what angle is this guy here? Let's call it X. All right. We have side, side, sides. We have to use cos. And I need to solve for the angle. So that's my end, my one piece of bread, cos X. Its partner is 2, so that's what's starting my equation. 2 squared, 6.5, and 8 is the peanut butter and jelly in the middle. So 6.5 squared plus 8 squared, subtract 2 times 6.5 times 8. All right, let's simplify. We have 6.5 plus 8 squared. I'm going to do that chunked together. $106.25. And then I can chunk this part together. That's negative 104 cos X. Now remember, we can't subtract 106.25 from 104. We have to get rid of the 106.25 first. And then we can deal with that 104 that's being multiplied by cos. And we can divide by negative 104. Starting to run out of room. Let's see, what did I have? Okay, I couldn't find my negatives in my calculator, so I do know that two negatives make a positive. So we have 102.25 divided by 104. And I get 0.983. 0.983 equals cos x. We have to do the inverse of cos to solve for my answer. Inverse of cos, and my answer equals 10.53. So that is the angle needed for that shot. Okay. Example 1, in triangle DEF, so I need to draw that out. Triangle DEF, here's D, here's E, here's F. Length D, which has got to be across from angle D, is 23.9. Length E is 16.8. And length F is 27. It wants to know what the angle D is. Oh, lovely. Another angle question. So its partner is 23.9. It's going to start off the equation. Cos of the angle I'm solving for ends the equation. The other two values are thrown in the middle. Okay. So 23.9 squared oops, 23.9 squared equals 57121. I'm going to do this one chunk together. 27 squared, 16.8 squared. (16.8 squared). That equals 1011.24. And I'll chunk this part. 2, 27, 16.8. $907.2. Cos D. We're going to subtract both sides by 1011 to get rid of that guy. So 571.21 subtract 10, 11.24 equals negative 440.03. There we go. Okay, divide by negative 907.2. So I have, now once again, I don't know where my negative is on this calculator, so I do know that a negative divided by a negative is a positive. So 440.03 divided by 907.2 is 0.485. 0.485, and then I have to imply the inverse of cos. And the answer is 60 point, we're going to round that to 61. There's your angle. Okay, I would like you guys to do page 55, textbook, and question 1, AC, number 2A, 3A, 4A, and 7.